NMR spectroscopy by Nicholas Chin. NMR spectroscopy. NMR stands for nuclear magnetic resonance. Basically, NMR spectroscopy is done by placing a protein into a strong magnetic field, then analyzing it using radio waves, which can be used to make a graph. So let me guide you through the process of NMR spectroscopy. In order for NMR spectroscopy to work, the nuclei of the atom must have an odd number of protons or an odd number of neutrons. These are atoms like hydrogen, boron 11, and carbon 13. As another example, helium 4 will not work because both the number of protons and neutrons are even. This is because atoms with an odd number of protons and or an odd number of neutrons have a property known as spin. Now, nuclei of atoms are charged. Therefore, it has a magnetic field. Anything with a charge does. So nuclei with a spin has their own magnetic fields. These atoms with a spin are called NMR active. Atoms without the property are called NMR inactive. To make it easy, I will be using magnets to represent the nucleus of an atom. Usually, NMR active atoms just float around in whatever way they like, just like the image shown. But when we put NMR active atoms into a magnetic field, which are shown by the arrows, the magnetic spins are aligned, like shown. These are called spin states. There are two spin states. Against the field and with the field. Of course, against is higher energy and with is lower energy. Now, if we look at this image, this perfectly shows how the high and low energy spin states are. The gap between the high energy spin state and low energy spin state is also known as delta E. When radio frequency matches the delta E, the RF radiation gets absorbed. RF stands for radio frequency. When this happens, the spectrum will show like this hydrogen in the form of a peak. In a protein, there are many atoms, and therefore there are many nucleuses of atoms. So there are many peaks like this, some high, some low. This creates a graph that looks like this. Using this data, scientists can create a 3D model of the protein. First, the graph is analyzed to show which atomic nuclei are close to each other and which atoms are bonded. Using this information from NMR spectroscopy, scientists can determine where each amino acids go and create a 3D model of the amino acid from this information. Using NMR spectroscopy comes with some advantages, the greatest of all being that using NMR spectroscopy, the amount of proteins we can find, the 3D structure greatly increases. Before, X-ray crystallography was the only used method, but with X-ray crystallography, many protein structures were not determinable due to the fact that they cannot be crystallized. The structure of these proteins that cannot be crystallized can be found out using NMR spectroscopy. But NMR spectroscopy does come with some disadvantages as well, one of which is that NMR spectroscopy can only solve the structure of small to medium-sized structures. In addition, NMR spectroscopy will not determine the protein's tertiary structure. Therefore, NMR spectroscopy will most likely be used in certain circumstances where the protein structure cannot be determined by any other methods. NMR spectroscopy was discovered by Bloch and Purcell in the year 1945. Bloch and Purcell. They were given the Nobel Prize in Physics in 1952 for their outstanding findings. Kurt Wuthrich was awarded the Nobel Prize for Chemistry in 2002 for finding out how to use NMR to figure out the 3D structure of molecules. Wuthrich's findings made protein NMR possible, which were later on discovered, and here's him getting the Nobel Prize. Thank you so much for watching, and here's the works cited. Again, thank you so much for watching.